Hi, in this video we'll see how to program the OmniChat, a Streamlit web application in Python that will allow us to interact with the new GPT-4o model that OpenAI just released last week. We'll see how to interact with it not only with text but also sending images and audios. We'll need to use Whisper and text-to-speech to send audio and receive audio from the model because GPT-4o is not able yet to produce and receive audio, but we'll see how to manage this with the OpenAI API, and we'll also see the cost of it. So here you can see how much I'm spending with GPT tokens, and for example today with the many tests that I've been doing and many interactions with the application, building this app and doing many experiments, I've been spending only in total 12 cents, so it's not expensive. If you are worried about spending much money with API, don't worry, you can pay as you go. This month, for example, I only spent $1 and something, so it's really cheap. You can put $1, $2, $3, we'll see how to do it, and only spend that. So you won't need to spend like $20 per month, for example, as people is paying for the ChatGPT Plus. So you will be creating your own ChatGPT, your custom ChatGPT application, let's say. And as you can see here, I was testing it now, so it's able to receive text, images, also audio. We can speak to it. We can put images from our device, our computer or mobile phone, or from the camera, so from the files or from the camera. And also we can activate this audio response to receive the response from the model.
Of course.
Let's
Here's
see.
another one. Why did the cat wear a life jacket?
So you can see that it's working. We can activate or deactivate the response. We can choose the model. And at the end of the video, we'll see also how to deploy this application into the Streamlit cloud for free. We'll be able to share it with everyone, and people will be putting here their API keys, so we don't have to pay for this. We'll see how to do all of this, and you will find the blog of this video and the code in the description. So go to the description to check the link of the GitHub repository if you want to follow the code. And also you will find the blog of this video. So why to create your own ChatGPT application? So well, first of all, it's a safe way of using ChatGPT, let's say, or the GPT-4, GPT-3. In the ChatGPT application, the public one that everyone knows, by default, they will use your conversation to train their model, so your data is not safe there. You can deactivate it, but by default, it's not deactivated. Also, you will be saving money because, as you've seen, it's so cheap, so you don't have to pay $20 per month to have these services. You can program your own application and save money. You pay as you go, pay per token, and the tokens are so cheap nowadays. With GPT-4 Turbo, the cost was around $10 to $30 per million tokens, so normally you don't spend even $5 or $10 per month. And now with GPT-4o, the cost is half of it, so you will be spending half of what you paid before for GPT-4 Turbo. So now, for sure, it's the best model to use. It has the same capabilities of GPT-4 Turbo, but better, cheaper and faster. Okay, so let's see how to program our OmniChat Streamlit application with Python, and later we'll see how to deploy it for free. So to start learning how to use the OpenAI API key, we'll create the folder of our project, and now we have to go to the platform.openai.com. And here we will need to create a new API key. If you don't have an account, you have to create an account first, of course, and you have to put also a payment method. Here in settings, you can go to billing, and here you can put a payment method. You have to charge some credits in advance, so now it's different as before, but you won't spend more than the money that you put here. Even so, it's really cheap. You can put only $5 or $10. You won't need more than this. Then whenever you have some credits, you can finally go to the API keys and you can create a new one. I just created one for this project that you'll see now. So whenever you create it, you have to make sure that you copy it, okay? And whenever you copy it without looting it, we can come here, create a new file, call it .env, and here we'll put the OpenAI API key as an environment variable. And now we can put here like this our API key. I will be deleting this one after the video, but make sure that you don't share this publicly. So the first thing, just in case, it will be to put here the .gitignore file. So this will make sure that if we put this project publicly in GitHub, that we don't share our credentials or our API keys, let's say. So in this .gitignore file, we have to put these files that we don't want GitHub or Git to track. Okay, now we have the gitignore file, so we can, for example, create the Git repository like this, git init -b main. Okay, now we have this repository created in our folder, and now we can create the virtual environment for Python. That is also a good recommendation. Now we can activate the virtual environment doing benv scripts activate. And now we can already install the needed libraries for now to test the OpenAI API. Like this, pip install OpenAI API kernel and python.env. So now we'll create this notebook, API experiment.ipy notebook, okay, here. And in this file, first of all, we'll import these libraries, OpenAI.env and OS. And also we'll load the .env to load the variables that we have in this .env file. And now we run this cell. We have to tell the notebook which kernel we want. So the virtual environment one, very important, not the normal Python version. And now in the next cell, we can instantiate here the client like this, and we have to put here our API key. Now here we'll be creating the question, the prompt that we want to introduce to the model, and we will be doing the request to the model like this, and we will choose which model, GPT-4o, that is the new one, but this could be GPT-4 Turbo, GPT 3.5. We have to tell here which model we want to call. Then we create here the messages like this in this format. So messages is a variable that it's a list, and every new message it's a dictionary. So this is a conversation, and every new message that we call to the API, we send all the conversation as this format, let's say, as a list of dictionaries, where we tell the role. In this case, it's the first question. So the first message, let's say, only the user is doing this first question. But if we wanted now, after the response, to put the second question, we'll need to create like a second message here, like this. And the role would be assistant. And here the response from the assistant, and so on. And then our next question in here. And here the second question, the second prompt. But for now, let's try to do the first question and see how it responds. And also here you can see that the type of this message, so we specify the type of every message, and in this case it's text, and then we tell the text it's equal to this prompt of here. But now that these new models allow new data types, this could be also image URL to introduce here then not the text but the URL of the image in base64. We'll see later how to do this. Here we can put some optional parameters like the temperature, the max tokens, or some other more advanced ones. It's optional to put those values or leave it as default without introducing them here. And finally, this response that we receive here, we can print it here like this. Choice is 0, message, and content. Let's run this to see what it returns. And this is the response from GPT-4o to our question. Quite accurate. It's a basic question. So, okay, this is how we use the API with Python basic. We can do this more complex and also introduce images. But now let's start building our chatbot application. For this, we'll close these files of here, and we'll create our file for the chat application, the Streamlit application. We'll call it app.py. And now let's start by importing all the needed libraries for the project. So first of all, we'll start by creating this stream LLM response function, and this will allow us to do queries to the model. So we'll be doing this request to the OpenAI API, but in this case, it's slightly different because we have here a new parameter that is called stream that we put to true. And this will be very helpful because instead of waiting for the full response to be created, we'll be getting in a for loop. You can see here for chunk in the full response. So we'll be receiving the response in chunks while it's created in the server. And we'll be receiving these chunks and we'll be appending them to the total message and also yielding in this function. So we'll be yielding these results. So Streamlit can already show from the beginning all the message how it's created, and we don't have to wait for the full response to be created. So this function will be returning the response in streaming to the Streamlit application, and at the end it will be appending the full response message to the session state messages, that is the variable that stores the full conversation in order to not lose it. So this is a helper function that we have been creating here. Now let's start creating the main function of the application and the configuration of the page as well. And also we put here the title. So I think that we can already see this, how it looks like. We'll see only the header for now. Let's save this file. And also we have to put here if name equals main. Otherwise, this won't run. So we'll be calling now the main function. And now in order to try our basic application, so far it's only the title and the page config, we'll need to install also some more libraries. So Streamlit with the version at least 1.34, that is the current one so far. And also audio recorder Streamlit the 008, because the latest one has some problems. and python.env. So we have to install it like this. Okay, you'll find the blog and so on in the description, so you can copy it from there. And now let's install these libraries. And after installing them, we can already try to run our application with Streamlit run app.py. So this is our entry point for our main file here in our folder. Okay, we have to be in the terminal in our folder and the virtual environment all the time activated to install all the libraries and also to run the application. Let's run this, and a new window will show up in the browser, or you can go to localhost and 2501. And now we see here at least the title and the website is running in our computer. So the server here is our computer, but so far it's looking good and Streamlit at least is working. So let's put our code and our application side by side to see it better. And now the next step will be creating the sidebar like this with st sidebar, and we'll be declaring like this the default OpenAI API key. Because with this method, this will allow us, if we are in our computer developing the application in the local host, it will detect the OpenAI API key, and otherwise it will put an empty string. So if this application is deployed in the server, like the Streamlit cloud for free that we will see later, in there we won't put, of course, the OpenAI API key in the environment variables, because we don't want, or you can put it if you want, but it's not a good idea to share the API key with everyone because they can spend money for you. So if it's a local environment, it will find this OpenAI API key, otherwise we'll request it to the users. Other users and your friends will be able to use your application, but if they put their own API key. Let's save this and let's check how it looks like in the website. We have to click always rerun. And now we see here that with the popover, it's requesting the API key from the user. Now it finds it here because it found it in the environment variables, and as it found it, it put it here the default value of the API key. And as it's the type password, this text input, it's putting this A of here and it's hiding it. But when the users come to your website that it's publicly online, this will be empty and they will have to put it. Now let's keep moving forward. And we'll start here the main content part, and we'll continue here only if there is an OpenAI API key. So if the user already put their OpenAI API key, we'll continue, and if it's empty, so if OpenAI API key is empty, we'll ask the user to introduce their API key. Let's check it is, let's save, and now it's not showing this, but if we remove the API key, let's put it like this. Now it shows here that it's asking the user to introduce the API key. Otherwise, they won't be able to do API requests, so it doesn't make sense to continue in the code. Let's refresh the website to load it again. Okay, now we have our API key from the environment variables. So this use case is when the API key is missing. Else, if there is an API key, then we want to instantiate our client of OpenAI with the API key that it's already here, so it's not empty if we are at this point. And if it's the first time, so if messages is not in the session state of Streamlit, we'll create the messages empty, the messages list, so the history, so empty so far. And then in this for loop, we'll be displaying every message of the session state messages. So in the initial run, this won't run because the list is empty. But if we already did some questions before to the model and some responses from the model, so this is not empty, we'll be displaying for message in session state message. Every message can have different content, so every user can have one content or multiple contents. And so far, we will have only text in this basic case. So if content type is text, we will write this text here. Later, we'll see how to add also images in here. So far, let's put this, but it will be empty for now, probably. And okay, we don't have any message, so we don't see any message here. So now we'll introduce here in the sidebar some options for the user to choose which model to select. We'll put here different options. There are some more models, but you can put even less of them because only the 4o and maybe the 3.5 Turbo, if you want something cheap and fast, are useful nowadays. But the old GPT-4, it's slower, more expensive, and worse than the newer ones. But well, it's good for comparison if you want to leave them. So we'll put this in a select box, then we'll let the user to choose some optional parameters if you want. I put only the temperature so far. You can add more of those extra parameters that we saw before. And we'll put those two parameters, the model and the model temperature, in this dictionary. Then we'll create this function to reset the conversation. So this will be deleting the messages in the list of the session state, and it will start from scratch the conversation if we want to start a new conversation, so we don't have to refresh the full website. Let's load this, and now we see here in the sidebar the different models that the user can select. And the model parameter you see here in the popover. This is so cool, a new feature from Streamlit. So we can select another temperature. With larger temperatures, the response can be more wrong, but also more creative. This depends on the use case that you want. If you want like a brainstorming, maybe a high value like 0.5, it's okay. But if you want something more safe, more secure, you can choose a slower value. I usually put 0.3, which is something quite balanced, let's say. And now the final step for our basic chat application will be to add the prompt from the user. So to get it from this ST chat input, this new element from Streamlit. If this chat input returns some prompt, if this prompt is not empty, then we'll be appending the prompt to the session state messages here as the role user and text and prompt. Then we'll be displaying this prompt in the main chat, let's say. And then we'll be using our Stream LLM response with the chat history that it already has, and with the client and the model parameters. So now we see that passing this client and the model parameters, we go to this function that we created before, and we have the client here created and the parameters of the model. And also it gets from the context of the application the Streamlit session state, and it takes all the messages, even the last one that we just introduced, from the prompt of the user, to query the model and receive the response in this stream mode, let's say. So this is the last part, the chat input. Let's save this. And now we see that it just appeared here, this input string bar. So let's try it now. Let's put, hello, tell me a story. So it's returning now like a quite long text. And you see that we don't have to wait for the entire of it to be created. We can see it while it's being generated. Also, we can see that it's quite much faster than GPT-4 Turbo. We can try now the same message with GPT-4 Turbo. Let's reset the conversation. Okay, it works. It deleted all the messages from our conversation. So let's send now from GPT-4o to GPT-4 Turbo. Let's put the same message and let's see how fast it goes. Okay, we can see that it's so much slower. So in fact, GPT-4o, I'm not sure how faster is it, but I would say that at least 3, 4, 5 times more. So we have our basic chat application already working, and now we'll be introducing more features and the capacity of putting audio, putting images, and also to receive audio from it using Whisper and TTS, because the API doesn't allow us yet to put audio or receive it, but we'll have to do it like this for now. Okay, so we'll go to our code here, and now in this utils function, let's say, that we are creating here, we'll need to create a new one that is this one to encode images from bytes to base64, so this string format, to send it to the API. We have to create it. We already imported before bytes.io, and this will be getting an image from bytes and decoding it to base64 like this and returning it. Now, after creating this function, the next thing will be to come here and we'll be adding, as I mentioned before, for every message in the conversation, if it's a type text, we'll be writing it. But now we can also have type image URL. So if the next message is an image URL message, we want to not write, but use the ST image to display it in the conversation. And we'll be displaying the content, image URL, and the URL of the image, which is the image in base64. So now in the sidebar here, we'll introduce a new option to put images, but not all the models that we had in the list of available models, not all of them allow to put images as input. Only GPT-4o and now also the latest versions of GPT-4 Turbo allow them to pass images. So let's reset the conversation, and if the selected model is one of those, is in this list, then we'll add this title here, and we'll develop 2 options to introduce images. And the 2 of them will be putting here this callback function. And we'll be able to put images from our computer, so uploading images, or also from the camera of the device, so from the mobile phone or the computer. And this callback function will take any of these images that will be in bytes format, and it will open it the bytes, it will transform it to base64, and it will be appending this base64 as type image URL, and here it will be putting the image as base64 format in here, and here the image type. So this will be the callback function for the two methods of inputting them, and we'll create now these columns called image. And now the first column will allow us to upload files from our computer like this using the onChange callback function that we just defined here. And this PNG, JPG, with this we'll be able to also put the widget of the camera. And very similarly, we call onChange add image to messages, the same function, because it takes either uploaded image or session state camera image. That it's this byte format image that we are getting from these two elements of Streamlit. So let's save this for now. And now we see that we have these two options here added, very compact with the popover, so we don't spend much space. Also the camera for extra security. We allow the user to activate it only if the user allows to activate the camera. Now we don't see it because I'm using the camera of my computer to record this video, and also upload images from your computer with this button here. But so far it's introducing the images to the chat. I'm blocking the chat conversation, so let's put it here to test it. And now let's upload some image to test it. And I have here in my computer this example image. It can be any image in any folder of your mobile or your device. So let's upload this image, and we see it here now. It's open. And now that we uploaded an image, it's not yet querying the model because we are waiting for the prompt to query the model. So let's ask what animal is there in the image and what is doing. And we are asking this with GPT-4o, okay? This could be also GPT-4 Turbo, and it already replied. The image shows a cat wearing a life jacket. So yeah, it's understanding pretty good. Is it normal, that situation? Let's see what it does. So we are sending the full conversation every time to every new request, and the image is embedded as a new message, the base64 image. And okay, it's understanding that no, it's not normal for a cat to be wearing a water ski. Cats really do not enjoy water. It's working. We see that it understands the context and what's happening here. So, okay, now we have already image as input, text as input, and we'll be adding a new modality of data here. And this will work for any model. So not only for GPT-4o or Turbo, that we have here these images methods only for these two models, but this will work for any model because the audio input will be transcripting it to text, and this will be a text input that will work with any of the models that we listed before. And we'll be using this audio recorder Streamlit component that we imported here in the beginning, this audio recorder Streamlit. This is a community component that allows us to put a microphone there and take audio input from the user. So we'll be taking the speech input, this bytes audio file, and we'll be making sure that every new audio to be introduced only once. So for this reason, it's slightly complex with hashes and so on, but it's only making sure that the audio file is new every time. So if there is a speech input and it's different than before, we are using also the OpenAI API with the audio methods, transcriptions, and we want to create a new transcription using the model Whisper 1. And we are telling the API that this is the audio bytes and this is the format of these bytes. And this will be returning this transcript that has a text in it. And this will be directly the text string of the audio that we pronounce here. So let's save this and let's see how it looks like in the website. So as we see, we have here add image, and now we have here add an audio. So we have to press here the icon, not the text, but the icon. And if we press it, hello, how are you doing? It's not yet working because if you see here, we are receiving the transcription and we are having it here as audio prompt. We still have to introduce this to the session state messages. So let's continue now to put this into our conversation. So what we will do now here is to use either the audio prompt or the normal prompt from the text input of here. If we have either a prompt or audio prompt, we want any of those two to be not none, so to have any string value, then we'll be adding this prompt to the conversation. So here again, we'll put the text will be either the prompt or the audio prompt. In this way, if prompt is none, it will get audio prompt, but if prompt is some text value, it will get the prompt, not the audio prompt. So it's taking one or the other if we have input in some of the places. Normally, we'll have one or the other one. So now we are already sending the text to the model, so to the message history. So now in theory, this should already work. So I will be saving Control S, our code, and let's go here back again. Let's reset the conversation and let's ask it, hello, how are you doing? We see that it's running, hello, okay, it get my audio. So I just speak with my microphone and it get the audio. Hello, I'm just a computer program, so I don't have feelings. So it's basically taking our audio, transforming it with Whisper to text, and it's the same way as we put here, hello, how are you doing at the end. So the model, GPT-4o, receives this as text, but it allows into our UI to have this conversation mode. If the user cannot speak, if it's in the mobile phone or so, now it can also introduce the text with the audio. Okay, let's test another one. Say something interesting about large language models. Okay, you get it correctly, and it's telling this. Okay, so it's working. We have here our speech-to-text function now, so we can introduce text in here. We have images from the file folder or from the camera, and also now we have audio. We have already 3 modalities of input data. And finally, what we are missing here is to receive the response from the model as audio. So GPT-4o cannot return directly audio, but we can do the inverse of speech-to-text, so the inverse of Whisper with the text-to-speech models. So now we will introduce this new function to get the text response from the model and creating a voice from it. To do it, we'll go here to the sidebar and we'll introduce this option to the user, because sometimes maybe the user don't want to get the response from the model as audio. Maybe the user prefers text, but if the user wants to have a conversation, like talking to the model and receiving the model voice back, we'll add this option here. So we'll put here this toggle to choose if the user wants to have audio response, and the default value will be false. So by default, it won't return the audio, but if this is activated, then it will generate the audio. And we'll add, in this case, 2 options here to select the voice, because this text-to-speech model has different voices available, some more feminine, more masculine with different tones, let's say. These are the available ones. And also there are 2 versions of the text-to-speech model, the TTS1 and TTS1 HD. This is slightly worse but faster and also cheaper, and the HD version is better but slower and slightly more expensive. Even so, all of those models are really cheap, so don't worry about making this test. Let's save this, and now here we see this new toggle button that appears here. So if audio response is true, this will be appearing. So let's put it at true. And now we have here select voice and select a model. We have the voices, we can change it, and also the text-to-speech models. By default, I put the high definition one, but maybe the user wants more velocity and less quality, let's say. So that's an option. Okay, now that we have these options here, we still need an extra step. And now we have these options, but we need the logic. So now here, after receiving the response from the model, here in the stream LLM response, that it's appending the response to the session state messages, we'll be introducing this code of here. So if audio response is true, then we are calling this other model from the OpenAI API. This is client audio speech, not transcription, but speech. This is another one. The model is the TTS1 or TTS1 HD as the user selects, the voice that the user selects, and the input will be from session state message, the last message, let's say, the last message, content, and text. So this will be, after this stream LLM response, this will always append a new message to the session state messages, and this will return an audio file in bytes. And we have to do it like this because there is an ST audio component, and in theory it has an autoplay function that if you put it to true, automatically displays the audio, but it didn't work for me. So I had to create this custom, very basic HTML component. You see it's only 3 lines of HTML. And here we have to convert the response from the speech model, so the audio in bytes format, to base64. And with this audio controls autoplay, this autoplay will make that whenever this is generated, it starts playing in the chat. So the user don't have to manually play because it's more natural, like a conversation. And we are introducing this HTML component in here. We can use the new HTML method. And also here, this is optional. It was just in case, but we don't really need it. So let's save this and let's check now. Okay, we have audio response activated. So Let's have a new conversation. So let's try to generate something in short to not have a very long audio. Let's ask it like, "Hi, how are you doing?" And okay,
Hello,
let-
I'm here and ready to help you. How can I assist you today?
okay. So we see GPT-4o return this text, and then with the TTS model from OpenAI, we are transforming this text to audio immediately, and we have it here automatically display because we use this HTML component that automatically autoplays it, and it's automatically playing, and it's quite fast, let's say. And with TTS1, and let's try some other voice, it will be slightly faster. But it's almost real-time conversation. It's not so good as the latest version of GPT-4o from the demonstration of OpenAI, but well, it's almost real-time conversation. Let's try it again with this other voice. Tell me something interesting. So we have some seconds between the generation of audio and so, but it's
Sure.
the better we
Did you
can do.
know that octopuses have 3 hearts? 2 of the hearts pump blood to the gills, while the third
Okay, let's pause it. So here we change now the type of model. It was the voice slightly worse and also the voice type, and it worked. So here we have our OmniChat with 3 modalities. It's multimodal, it's omni-modal as they say it now, with GPT-4o and the other ones, and returning either text or also audio. So it's pretty interesting, all the possibilities. So now let's see how to deploy this to the Streamlit Cloud for free. And first, we'll need to upload this to GitHub. So we already created our Git repository, but now we'll need to git add our code. Also, I was forgetting, so let's revert it because we need to generate the requirements.txt file with virtual environment. So let's activate the virtual environment again. Let's kill the application here in the terminal. Okay. And now with the BNB activated, we have to do pip freeze. This will return all the libraries that we install. Requirements.txt. This will generate this requirements.txt file and with all the dependencies. And also, if you are in Windows, make sure that this pywin32 is not here, so you can comment it. This is installed only in Windows, as I am now, but the Streamlit Cloud runs on Linux, and if a Linux environment or a macOS environment finds this library, it will crash. It will throw an error, but anything else should be okay. So now we have the requirements.txt file here. We save it with the modification. So now we can do git add, git commit, project completed. Okay, so now we'll go to github.com. You have to create an account if you don't have it already. And let's add here a new repository. So let's call it the OmniChat, and everything else can be as it is. And now, as it says here, if we already have here the Git repository created and we did the git add and git commit, if all of these work, we can do these steps of here. So let's copy them. This will push our code to GitHub. So add the URL of our repo and let's push the code to the repo. Okay, if you have SSH, this is the way of doing it. If you don't have the SSH keys configured, you can do it with HTTPS and it will request your authentication. Now, if we reload here our repo, we see the code and we can go now to the Streamlit website. And here, if you don't have an account, you can sign up. I will sign in. It's better to do it with your GitHub account, but it will work also with Google. But you will need to link the GitHub account later somehow, so it's better if you start doing it with GitHub. So now we'll go here to create app, and we have to get our repository, then the branch that in this case is main, the file path that for our case is app.py. So make sure that this is correct as we put it here. So the same name of our file. And now here we have to select the name of our application, the URL name. We cannot change streamlit.app, but we can change at least the subdomain. So let's put the OmniChat as the URL, the /OmniChat streamlit.app. Let's deploy it. Now it will take some seconds, not even a minute or two, but it can take up to 1 or 2 minutes, is normal. Here we can check if you are the owner of this app, you can check here the logs. If something happens, so if you have any error, you will see it in here, the problem, to understand what's happening in the server, in the Linux server while you deploy it. So now let's wait some seconds. And yeah, in 20 seconds or less, it worked. So now we can hide this. And now we have here the OmniChat. The default theme, it's dark mode for me, but here I can put it in light mode. And here now in the server, it doesn't have the environment variable for the OpenAI API key. So I have to introduce mine. Let's put here the key, and now it's working. Okay, so now this is running in the server, so not in my computer. So if this works now here in this URL, it will work in any computer, in the mobile phone, or in any device. Even for your friends, if they have an API key, they can use it, this application. And let's try now. Hello. Okay, this works. Let's upload an image. The same one of the cat. Okay, uploaded, it worked. Is this normal? Okay, it works. Now let's try the audio. So we already tried text, image. Let's try the third modality. Now you can see here it's asking to use the microphone because this is a new application, not the localhost one. Tell me a joke about this image. Okay, and now let's try the audio again. So let's use the default parameters. They are okay. And let's say, tell me another one.
Of course. Here's another one. Why did the cat wear a life jacket
Okay,
while water skiing?
it's working.
Because it didn't want to waste any of its 9 lives.
Well, I don't know if it's funny, but it worked. Okay, so that's it. We have here our OmniChat working with the 3 modalities online for free. Well, for free, the app deployment. We'll have to pay for the tokens, but if we go now and check what we have spent so far, here in the settings, billing, you can see that it was 870 before, and I only spent like 10 cents in all of these tests, creating responses with different models, sending images, sending audio with the Whisper model, sending text to receive audio. So we tried different models. We did many requests, and I think that I only spent like around 10 cents or something like that. So yeah, that's it. You'll find the code here in my GitHub if you want to check it. Also the Medium blog in the description. And make sure to subscribe and give it a like if you enjoyed this content. Let me know what you think about it, and if you have any questions, leave it in the comments. And also you can check my oldest videos in the channel that I explain other things about Streamlit and other use cases for GPT-4 Vision, the previous model that OpenAI released. And in the future, if OpenAI releases more models, or if they introduce audio to the GPT-4o, we'll introducing this to this application. So make sure to subscribe because we will be updating this application if they introduce new features to the API. So that's it. See you in the next video. Bye.